Alright, so we are simplifying. We're adding and subtracting radicals, and sometimes before we add and subtract radicals, we have to simplify, because what we need to do is simplify to get like radicals. Something that has like radicals are radicals that have exactly the same index and exactly the same radicand, the same key to get inside the house, and the same stuff inside the house, the square root house. These are like radicals. These are like radicals. They could be added or subtracted if you need to. So we've gone through a couple different ideas, and right now we're going to simplify. We're going to go to a couple more examples of number 6 and number 7 down here. 4x times the square root of 12 minus 27x squared. All right, these guys down here, let's see, like radicals? Not right now, because we got a square root of 12 and square root of 27x squared. Let's see if we can simplify these guys and maybe get them to a like radical situation. All right, we're going to separate and conquer. I got a 4x outside the house. Square root of 12 can be rewritten as a perfect square times, you know what, I'm going to simplify that as well. I'm just going to take a shortcut. Square root of 4 times square root of 3, because 12 is 4 times 3. 4x, square root of 4 is times 2 times square root of 3. Remember, all this stuff is multiplied together. Make it prettier. 4 times 2 is 8x outside the house. Square root of 3 is still inside the house. All right. Now this is simplified as 8x square root of 3. Let's see if we can find this to be simplified as a square root of 3. I'm guessing we can. Separate and conquer. Square root of 27 gets its own house. Square root of x squared gets its own house. Square root of 27 is square root of 9 times 3. 27 is 9 times 3. Square root of 9 is 3. Square root 3 stays inside the house. Square root of x squared is x. Square root of a perfect square means the base, x, comes outside the house. We got an x. Now let's make this prettier. I got 3x. Square root 3. This one is 8x. Square root 3. Now they are like radicals because they both have square root 3. 8x minus 3x. Add up or subtract the coefficients, these that are in front of the square root of 3. 8x minus 3x is 5x. Square root 3, done. Simplified as much as we can. Take a look at this guy. He's going to be complicated, I think. 28y cubed. All right, separate and conquer. Square root 28, because right now, as they're given that term, that term, that term, not like radicals. All right. Let's see what we can do with them, though. Y cubed. Don't see how much space we got. I'm going to have to probably extend my page soon. Might as well do it now. All right. Square root of 28, square root 4, square root 7. Y cubed is square root y squared, square root y. Because we want a perfect square inside the house. Perfect square and something else. Perfect square, something else. Y squared is a perfect square because it has an even power. Square root of 4 is 2. Square root 7 stays inside the house. Cannot be rewritten as a perfect square times something else. Square root of y squared is y. Square root of the perfect square means the base comes outside the house. Square root y stays inside the house. Make things prettier. Multiply things that are outside the house. Put them in the front yard. 2y. Combine. Square root of 7 times square root of y is square root of 7y. Just like separating and conquering, we can combine and conquer as well. We can combine this 7 and y inside the house. That stays inside the house. All right. I have a y outside the house for this term here. I got y outside the house. I got square root 63 gets its own house. Square root y gets its own house. Y square root, let's see, 63 is 9 times 7. Square root y stays inside the house. Y times square root of 9 times 3 times the square root of 7 times the square root of y. Let's make things prettier. I got 3y outside the house times square root of 7y. And that looks pretty good because now we've got like terms, like radicals that we can combine. Drop down this the minus sign. Put a minus right there. 700. What do we have for that? Well, let's see. It's square root of 700 is, well, let's see. 100 is a perfect square, so I'm going to rewrite it as 100 times 7. Square root of 100 is 10. Square root 7 is square root 7. Drop that guy down here. That's about as simplified as it can get. Drop the plus sign down here. I got plus. Combine like radicals. The blue and the green are like radicals, so I can combine them. 2y minus 3y is negative 1y. Square root 7y. And this radical over here is not a like radical, so he has to just stay as plus 10 square root 7. And we're done. Simplify it as much as we can because we cannot combine these two terms. Alright, those are two more examples, and here's a couple more examples as well. Well, let's see. Can we combine these? Can we add or subtract these? Well, let's see. 2 squared root of 7 minus 5 squared root of 3. Let's see. Not like radicals yet, so we can't subtract. Can we simplify? Square root of 7 cannot be rewritten as a perfect square times something else. Same thing as square root 3, because that can't be rewritten as a 4 times something. So this one is pretty much our answer right there. We can't simplify it anymore. And the same thing goes over here. 7 cannot be simplified. Square root of 5 cannot be simplified. So we're pretty much done, and there's pretty much our answer. Sometimes we can't simplify anything more, and we just have to leave things as is.